This is Yasin ALPEREN, and this presentation is for Communication System 1 in 2023. I made this project with Abdullah, Melih, KARACA, so I'm starting. So design target of this project is developing an acoustic modem and designing an experiment for one of the steps of digital communication system. So we wanted to show the algorithm diagram. So we are we are inputting in sound to our code, and we are encoding it with pulse shaping. Uh, we choose the Manchester pulse shaping because it's more effective. Then we modulate the signal, and we add the noise. We choose the white Gaussian noise. So and we transmit the sound, and we add to match filter for increase the SNR. Then we demodulate it, and we take the sound output. So project summary. First we take a sound sample and add it to our code. Then we adjust the pulse shape by encoding this sound sample and making it ready for the modulation. Modulation, we overlay our baseband signal over our passband signal. We choose M4 for M and QAM modulation. This is a spelling mistake. And modulation to minimize the error rate. Then we added the white Gaussian noise to this modulation. We then transmit this modulated sound that we have processed. By passing this incoming noise modulated signal through the matched filter, we amplify the SNR, increase it. That is, increase the ratio of signal to noise ratio, which is what SNR means. Then, by modulating this filter signal, we reach our baseband signal again. The diagram here in the project report is show our algorithm logic with diagram, which is the previous uh, diagram. And in this section, basic concept related to communication will be mentioned in order to analyze project better to who is not understanding the communication basics. So pulse shaping, we did we choose Manchester pulse shaping, as you remember. So what's pulse shaping? In electronics and telecommunications, pulse shaping is the process of changing the waveform of transmitted pulses to optimize the signal for its intended purpose or the communication channel. This is often done by limiting the bandwidth of the transmission and filtering the pulse to control intersample interference. Then we come to modulation in electronics and telecommunications. What is modulation? We are explaining here. In electronics and telecommunication, modulation is the process of varying one or more properties of a periodic waveform called the carrier signal with a separate signal called the modulation signal that typically contains information to be transmitted. And what's noise? In electronics, noise is an unwanted disturbance in an electrical signal. A match filter, why we are using and what is it? In signal processing, a match filter is obtained by correlating a known delay signal or template with an unknown signal to detect the presence of the template in the unknown signal. This is equivalent to convolving the unknown signal with a conjugated time reverse version of the template. The match filter is the optimal linear filter for maximizing the signal to noise ratio in the presence of additive stochastic noise. Demodulation, finally we get it. Demodulation is extracting the original information bearing signal from the carrier wave. A demodulator is an electronic circuit or computer program in a software defined radio that is used to recover the information content from the modulated carrier wave. There are many types of modulation, so there are many types of demodulator. After this, I am giving my turn to Abdullah Melih KARACA to explain how our code is working actually. Thank you.
Hello, my name is Abdullah Melih KARACA. From now on, I'm going to continue our presentation from our MATLAB codes. At first, this is where we record our voice. We We use an audio recorder object to record audio data from an input device such as microphone for our process. The audio recorder object contains prior properties that enable additional flexibility during recording. For example, you can pause, resume, or define callbacks using for audio recorder objects functions. Fs is our sampling frequency for recording. Record blocking, recorder object and length, records audio from an input device for the number of seconds specified by length. The record block method does not return control until recording completes. The recorder object is an audio recorder object that defines the sample rate, bit depth, and the other properties of the recording. Get audio data returns recorded audio data associated with audio recorder object recorder in a double array Y. After that, we reshape our record. Reshape function reshapes A using the size vector SC to define as size B. For example, reshape A to 3 reshapes A into a 2 by 3 matrix. SC must contain at least 2 elements, and prod SC must be the same normal as A. You can specify a single dimension size of something to have dimension size automatically calculated, such as the number of elements in B matches the number of elements in A. After that, we use our Manchester encoding. After our record signal reshaped to a binary, we encode it using Manchester encoding for a certain bit sequence. After this, we plot our unmodulated signal. Then we use QAM modulation. QAM is quadrate amplitude modulation. It is modulation scheme used by network operators when transmitting data. QAM relates to a way of changing the amplitude or power level of two signals. QAM enables an analog signal to efficiently transmit digital information and increases the usable bandwidth. After the modulation, we demodulate it. In this part, we demodulate our signal. At first, we use scatterplot, creates a scatterplot to display the input signal X in the IQ plane. Specifically, the IQ plane displays the in-phase and quadrate components of a modulated signal on the real and imaginary axis of an XY plot. After that, we reshape our signal again in here, and we get our demodulated signal. Thanks for listening to us.